There is a place in the universe where galaxies go to die, and we are moving toward it at 600 kilometers per second. In the vast tapestry of space, where billions of galaxies spiral and dance across the cosmic stage, there exists something that defies every expectation of what the universe should be. Something that shouldn't exist according to our models, our mathematics, our carefully constructed understanding of reality. An emptiness so profound, so utterly void of matter and light, that if you could somehow stand at its center, you would see nothing in every direction for a billion light years. No stars, no galaxies, no light that has traveled for eons to reach your eyes. Just darkness. Absolute, incomprehensible darkness. This is the boat's void, and it's hunting us. When astronomers first discovered this cosmic anomaly in 1981, they thought it was an error. Robert Kirshner and his team were conducting a routine survey of galaxy distributions, mapping the universe the way cartographers once mapped Earth, expecting to find the usual clusters and superclusters of galaxies scattered throughout space like cities across a continent. What they found instead was silence. A region of space roughly 250 million light-years in diameter where galaxies simply ceased to exist, where creation itself seemed to have forgotten to form. Imagine for a moment that you're looking at a wall covered in millions of photographs, edge to edge, every inch of space occupied by images of families, landscapes, moments frozen in time. Now imagine a perfect circle in the center of that wall where there are no photographs. Not because they fell off, not because someone removed them, but because they were never there to begin with. That's what astronomers were seeing, a hole punched through the fabric of cosmic structure itself. The scale of this void defies human comprehension. If our Milky Way galaxy were placed at its center, the nearest neighboring galaxy would be so impossibly far away that even traveling at the speed of light, the fastest possible speed in the universe, it would take you tens of millions of years to reach anything else. We struggle to grasp the distances between stars within our own galaxy, but this emptiness makes those distances seem like the space between atoms. It's a desert where even light itself has abandoned hope of finding anything to illuminate. But here's where the story turns from merely strange to genuinely unsettling. The Bote's void isn't alone. As our telescopes have grown more powerful, as we've mapped more of the observable universe, we've discovered that voids aren't rare cosmic flukes. They're everywhere. The universe isn't a uniform soup of galaxies as we once believed. It's more like a sponge, with galaxies forming along vast filaments and sheets, and enormous voids filling the spaces between like bubbles in foam. We live in what cosmologists now call the cosmic web, and most of the universe's volume exists in these lightless voids. The Bote's void is simply the largest, the darkest, the most profound example we've found, and it's growing. You see, the universe isn't static. Every galaxy, every star, every particle of matter is moving, flowing like water through invisible channels carved by gravity and dark energy. The cosmic web isn't frozen in place. It's dynamic, shifting, evolving, and the voids are expanding, pushing galaxies further and further along the filaments, concentrating matter into thinner and thinner threads stretched across an increasingly empty cosmos. The universe is being hollowed out from within. Our galaxy, our home, sits within the Laniakea supercluster, a structure containing 100,000 galaxies bound together by gravity's embrace, all flowing like a river towards something called the Great Attractor. This mysterious gravitational anomaly pulls everything in our region of space toward it with inexorable force. We can't see what it is clearly because it sits behind the obscuring dust of our own galactic plane, but we can measure its influence. We know it's there because we feel its pull, the way ancient sailors knew land was nearby, watching birds and sensing currents they couldn't see. But the Great Attractor itself is being pulled by something even more massive, even more mysterious. Beyond it lies an even greater concentration of mass called the Shapley supercluster, and beyond that, the true architecture of the cosmic web reveals itself in all its terrible beauty. Galaxies flow along filaments like blood through cosmic veins, and between these structures lie the voids, growing larger with each passing epoch. The mathematics of this expansion are disturbing. As dark energy accelerates the universe's growth, the voids expand faster than the filaments that surround them. Eventually, in the deep future of the cosmos, billions of years from now, these voids will have stretched so large that neighboring galaxy clusters will have receded beyond each other's cosmic horizons. They'll be moving away faster than light can travel between them. Entire populations of galaxies will become permanently, irrevocably isolated from one another, marooned on islands of light in an ocean of expanding darkness that can never be crossed. But something even stranger lurks within the mathematics of void dynamics. Computer simulations of cosmic evolution reveal that voids don't just expand passively, they actively push, exerting a kind of negative pressure that accelerates the evacuation of matter from their interiors. Any galaxy unlucky enough to find itself inside a void experiences something cosmologists call void repulsion, a subtle but persistent force that nudges it toward the void's edges like an unwelcome guest being shown the door. The few galaxies that do exist within the Boat's void are evolutionary oddities. Starved of the raw materials that fuel galaxy formation, deprived of the gravitational interactions that trigger star birth in denser regions of space, they're stunted, ancient, dying. They're galactic ghosts, fossils from an earlier epoch of creation slowly fading to black in their prison of emptiness. Their stars are old and red, no vibrant young blue giants, no active stellar nurseries birthing new generations of suns. Just the slow, cold descent toward eternal darkness. And here's the question that keeps cosmologists awake at night, staring at their data with growing unease. What happens if a thriving galaxy like our own crosses the threshold from the dense cosmic filament it calls home into the empty desert of a void? Would our galaxy survive the transition? Would we even recognize what we'd become? The current evidence suggests something profoundly disturbing. Galaxies don't just enter voids and continue on unchanged. The act of entering a void fundamentally alters a galaxy's nature. Stripped of the intergalactic gas and dust that feed star formation, isolated from the gravitational dances with neighboring galaxies that compress gas clouds and trigger stellar birth, a galaxy entering a void would begin to starve. Its spiral arms would eventually lose their blue glow as massive young stars died and no new ones formed to replace them. Over hundreds of millions of years, it would fade, redden, and finally go dark. This is the fate that awaits us if our motion through the cosmic web eventually carries us into one of these expanding deserts of space. The Milky Way, with its 400 billion stars, its countless worlds, its infinite possibilities, would become a ghost. And any civilization arising on any world within such a galaxy would look out at the night sky and see nothing. No other galaxies, no cosmic web, no evidence that anything exists beyond their own island of increasingly ancient stars slowly winking out one by one. They would be cosmologically alone in a way that we can barely imagine. But perhaps the most haunting aspect of the void phenomenon is what it suggests about the fundamental nature of space itself. Some theoretical physicists have proposed that voids aren't empty at all, that they're filled with something we can't detect, something that exerts negative pressure and pushes matter away. Dark energy, the mysterious force accelerating the universe's expansion, might be concentrated in these vast empty regions, making them not absences of something, but presences of something else entirely. Something we don't understand. Something that's winning the battle for the universe's future. If this is true, then voids aren't gaps in creation. They're the default state. They're what the universe wants to be. And all the galaxies, all the stars, all the matter we see clustered along the cosmic web's filaments are temporary holdouts against the void's inevitable victory. We're living in an anomaly, a brief moment of cosmic time when matter managed to clump together enough to form structure, to create stars and planets and life. But the voids are patient, they're expanding, they're winning, and we're moving toward one right now. Our entire local group of galaxies, bound together by gravity, floating through space as a unit, is being swept along by cosmic currents we're only beginning to understand. The dark flow, as some astronomers call it, pulls vast structures in our universe in a consistent direction towards something beyond our cosmic horizon, something we cannot see and may never understand. We're passengers on a ship we didn't build, following a course we didn't chart, headed toward a destination we cannot predict. The question isn't whether we'll eventually encounter a void. The question is when. And what will happen when we do? Will future civilizations arising in our galaxy find themselves cosmologically orphaned, their night sky empty of all but their own dying stars? Will they even know that other galaxies once existed, or will the evidence have receded beyond the horizon of the observable universe, taking with it any proof that they're not alone? The void is patient, the void is growing, and the void is waiting. The universe is 380 billion years old, but the age of galaxies, the age of stars, the age of light and warmth and possibility may be nothing more than a brief flicker between two eternal darknesses. We were born from void, and to void we may return. The question that remains, hanging in the darkness of space like an unanswered prayer, is simply this. When the last star finally dims, when the last galaxy fades beyond the cosmic horizon into the expanding emptiness, will anyone remain to notice? Or will the universe return to its natural state, that profound and absolute silence where nothing exists, nothing changes, nothing remembers that anything ever did?